Welcome to the Zero Zone presentation on natural refrigerant solutions to assist retailers in meeting the ever-increasing regulatory demands. I would like to say thank you to the NASRC for their continued commitment to the atmosphere, our planet, and our industry. I am Bruce Hurlmeyer, Director of Regulatory Compliance and Refrigeration Technology. I'm excited that you have joined us today. I look forward to sharing some ideas and solutions that can assist retailers in their low GWP goals. Today I'll talk very briefly about Zero Zone's natural refrigerant products. I'll provide a little background on Zero Zone and our capabilities. I will discuss Zero Zone's experience with CO2 in one industrial case study. Now moving on to our refrigeration systems. Our systems factory is located in the suburbs of Minneapolis. We are proud of our history of designing high-quality refrigeration systems delivered on time with outstanding field support. Our quality is built into the product through our stringent quality control system that is used throughout our manufacturing process. Zero Zone's 100,000 square foot manufacturing facility is quite impressive. 7 production lanes and a dedicated bay for building our large industrial systems. Our talented manufacturing team is cross-trained in many different facets. Our manufacturing flexibility allows us to do brazing or steel welding depending on the needs of the project. As you can see, we have been involved in many different applications over the years. Supermarket, cold storage, food processing, ice arenas, pharmaceutical and biomedical, and many others. Within our systems division factory in Ramsey, Minnesota, we house our research and development lab. The lab has been instrumental in developing our CO2 solutions. We have both a CO2 subcritical cascade and a CO2 transcritical booster rack in operation. We also use the lab for technical training for retailers, contractors, and end users. If you have interest in visiting our factory or learning more about CO2 training, please reach out to me via email. In addition to our R&D and training facility, Zero Zone has the ability to do run testing of units prior to shipment. We can run test a unit up to 100-ton heat load. This service is offered at an additional cost, but it is invaluable as it allows you to truly confirm all the compressors are operational, the ability to confirm all the transducers and sensors are functioning as planned, and last but not least, the ability to confirm the programming is operating the entire machine as intended. This ensures the equipment is ready to run when it is delivered to the job site. Now a little bit more about Zero Zone. Our headquarters and our display case division is located in North Prairie, Wisconsin, with ancillary facilities in Waukesha and Pewaukee, Wisconsin. All of them are suburbs of Milwaukee. Our fleet of refrigerated merchandisers are all CO2 ready and able, both for transcritical and subcritical operation. If you're looking for outstanding merchandising solutions, no need to look any further. Zero Zone merchandisers exceed customer expectations. At the Case Manufacturing Campus, we have our technology center that houses our showroom and our state-of-the-art R&D facility. Today I'm going to spend a little time reviewing some of the live applications that Zero Zone has completed over the past several years. Many of these were for new installations, but they could have easily been for remodels. I have an example of where Zero Zone provided a remodeled solution that allowed the retailers to lower their weighted average GWP. We have gathered and developed some of the brightest minds in the refrigeration field. Our entire team, from sales to engineering to production, and our field support team have one focus: providing high-quality refrigeration solutions delivered on time and at a competitive price. This starts back with the design phase and really focusing on the customer's needs and wants. It's critical to work through all the design elements, the what-if scenarios, incorporate all of that into the final product. The team is extremely critical in the design process, providing long-term solutions focused on serviceability and reliability. So let's get into the live examples of what Zero Zone has been doing recently. We'll start with subcritical systems. We were fortunate to be part of Relay's newest store. Their new store in Sacramento utilized a CO2 liquid overfeed system with 2 recirculating packages. The low temperature recirculating system had 2 pumps for pumping liquid CO2 to the cases and 2 cascade heat exchangers. The medium temp system also used 2 pumps, but utilized 4 heat exchangers. The system started up in early 2020. On the high side, Raley's built a custom mechanical room to house the ammonia compressors. As you can see in the photos, they used their traditional Carlisle 5H compressors, but used ammonia to cool the CO2 in the Cascade heat exchangers. I'm sure Ed Esberg would be happy to discuss their design in more detail if you have specific questions. During the NASRC event in January 2020, Mike Gallinger from Whole Foods, Brad Pearson and Russ Deal from SEER2, and Mike Hoffman from ZeroZone presented on a recent remodel. The existing store had 3 rack systems with R507. The low temp rack and cases needed to be upgraded as they were near end of life. This provided an opportunity to reduce the store's weighted average GWP. The remodel plan was to convert the 2 medium temp racks to R448A, replace the low temperature doors, and add a new low temperature CO2 cascade system. Doors were added to the medium temp cases to reduce the overall medium temp load and to make room for the low temperature cascade system. Please note the refrigerant charges on the slide are only an estimate. In this example, the remodel plan allowed for the store's weighted average GWP to go from 3,900 to 925. I know this is only a single store example, and most retailers are dealing with multiple stores within your fleets. However, the moral of the story is that there are ways to lower your weighted average GWP significantly with the focus on your remodel strategy. I know each remodel has its own unique challenges, but there are strategies to meet or exceed the CARB requirements as seen in this example. Here are some photos of the finished outcome. New low temperature CO2 rack with low temperature door cases, reduced medium temperature load by adding doors to the medium temp fixtures, installed new BAC Trillium condensers for the medium temperature racks. Overall, a system upgrade that allowed Whole Foods to significantly reduce their weighted average GWP. This is the last example of the subcritical CO2 systems. This is an outdoor parallel system, OPS for short, that is using R513A as the high side refrigerant for the medium temperature circuits and to provide cooling/condensing for the low temperature CO2 system. It has a welded steel frame with lift-up pneumatic actuators and is ready to be picked up and set on a roof pad. On to transcritical applications. As I walk you through the next several installations, you'll notice there is not a one-size-fits-all package. You will find our refrigeration systems are designed to meet the needs of the retailer. We've used all of the major control system manufacturers. In this instance, we have a CO2 transcritical booster solution packaged within a mechanical center. The mechanical center included the hot water and heat reclaim system for the store. The mechanical center was set on the roof of the building. It's a nice compact package that simplified the installation for the contractor while saving the retailer space, time, and money. Here's another transcritical booster system. This unit has a sheet metal enclosure to house the refrigeration system. This particular unit was installed in the parking garage under the store. The biggest challenge we had was maintaining proper superheat at the rack. With all the suction lines running downhill to the rack and all running through cool spaces, superheat control at the cases was crucial. Our field service team assisted the contractor to provide a reliable, long-term solution. Here's another CO2 transcritical booster system with a water-cooled gas cooler/condenser. A low-profile design was needed to meet the space requirements of the building. As seen in these first 3 examples, split suction rack systems can service part of or an entire store, depending on the size of the store. In Vermont, this retailer wanted to reduce their overall refrigerant charge and exposure. They've been using glycol to refrigerate the medium temperature cases and walk-in coolers, and they wanted to continue with that design. To reduce their refrigerant footprint, they decided to use CO2 on the high side of the chiller in lieu of R404A or R448A. Ultimately, they removed all or almost all of the HFCs from the store. Here's another retailer making the move to CO2 transcritical systems. The store has 4 racks systems utilizing adiabatic gas coolers. This store had a significantly more required capacity, 62 tons for the low temp and 125 tons for the medium temp. Back over on the East Coast, another CO2 transcritical booster system with an adiabatic gas cooler. If you're seeing a pattern with the direction of the market, more stores are choosing CO2 systems. Here we have another ops system with an end-mounted adiabatic gas cooler. The gas cooler is fully integrated, mounted, piped, and wired at our factory. Here we have an Edge XT unit with a back-mounted adiabatic gas cooler. The Edge XT is an all-weather unit designed for easy access and rugged reliability. All of ZeroZone's display cases can and have used CO2 either in a liquid overfeed or direct expansion application. The coils have a design pressure of 700 psi to make them suitable for higher low side design pressures. I know that the NASRC has primarily concerned with the supermarket industry due to the large number of stores, but I wanted to share performance information on an industrial application since there are many similarities. Let's review with you a dual sheet ice arena in St. Michael/Albertville, Minnesota. The community had an existing ice arena that had an old R22 system. It was time for the city to replace the 30-year-old system, and they wanted to look at a natural refrigerant solution. ZeroZone worked closely with the stakeholders to develop a transcritical CO2 solution that would fit their needs for the next 30 years. The chiller package was an indirect system where CO2 cooled the glycol, and the glycol is pumped to the floor to refrigerate the ice. It's similar in design as the supermarket in Vermont that I covered earlier. The system has 4 Bitzer reciprocating compressors for chilling the glycol and 2 Bitzer compressors for parallel compression to remove the flash gas from the flash gas receiver. The system utilized microthermal controls. 4 operating modes were evaluated for about a 1-month period of time. They included dry gas cooler and flash gas bypass operation, dry gas cooler and parallel compression operation, adiabatic wet gas cooling and flash gas bypass operation, adiabatic wet gas cooling and parallel compression operation. In analyzing the system performance, we used watt meters for energy consumption and pump curves to determine the amount of cooling so we could calculate the EER. Performance improvement was calculated against the baseline of a dry gas cooler operating with flash gas bypass. We measured larger energy improvements than we originally estimated during the design phase. On warmer days, we have a greater improvement in performance. You get more bang for your buck on hotter days. Dry gas cooler / parallel compression operation was 35% more efficient at 70 degrees ambient and 43% more efficient at 85 degree ambient. Ambient cooler operation with flash gas bypass was 11% more efficient at 70 degree ambient and 41% more efficient at 85 degree ambient. When the technologies are combined in adiabatic cooler and parallel compression, it was 31% more efficient at 70 degrees F and 51% more efficient at 85 degrees F, all compared to the baseline. The ice rink has a few differences when compared to grocery stores and some other details I would like to review with you. There are no low temperature loads, so our EER is higher than a grocery store would experience. The saturated suction temperature is lower than a typical grocery store's medium temperature saturated suction temperature, so our EER improvements with the adiabatic cooler and parallel compressor are greater. The benefits of an adiabatic condenser and parallel compressor drop off significantly at lower ambient temperatures. The annual operating conditions for the equipment needs to be evaluated when making design decisions on what to include in your system. The technologies did not provide fully additive improvements. Each technology improves the management of flash gas, so they cancel somewhat when used together. This was shown in the stepwise improvements in the EER values. Get involved now. The NASRC is here to help the industry move forward. The technology is here to assist retailers meet their needs with the pending refrigerant phase downs. When the time is right, please note we are happy to come and visit with you or set up a remote meeting, or when you feel comfortable, come to visit us. So to all the retailers out there, I ask you to come experience the zero zone difference.